Alrighty, hot dog. Here we're doing more problems with scale factor, dilation, but in this case we're dealing with word problems. We're going to work on a few problems where we're finding the scale factor, and then we're going to do a few problems where we're using the scale factor in order to. So we're going to be given the before size, and we have to use the scale factor to figure out what the after size was. All right. So remember, we talked about this before, but scale factor, which I'll abbreviate SF, is equal to after divided by before in a very general sense. So whatever the size was after the dilation divided by the size before the dilation is the scale factor. By the same token, before times scale factor equals after, and we're going to use that formula in the second set. So for this first set, we're going to be calculating scale factor by dividing after divided by before. Then later on, we're going to take the before size and multiply it by the scale factor to get the after size. Let's take a look here. An image of a celebrity is going to be used on a promotional billboard. The person is 5.75 feet tall in real life and 11.5 feet tall on the billboard. What is the scale factor of this dilation? So we've got our celebrity here. Yay! And he is 5.75 feet tall, and he is being blown up to this billboard size, which is 11.5 feet. So this is going to be our after, and this is going to be our before. So our scale factor is after divided by before. So scale factor equals after divided by before. Our after was the 11.5 feet. 11.5 divided by our before, which was 5.75. We'll get our trusted, dusty calculator here. And I'll go 11.5 divided by 5.75 is 2. So 2. Which means that the man's height is being doubled, multiplied by 2. All right? So there's a few more for you to try on your own here. Similar problems. Let's go down here to using scale factor. Remember, it's before times scale factor equals after. Let's see. The person in line in front of you at the store is buying reading glasses that say plus 2.75. If that is the magnification level of the glasses, how tall to the nearest thousandth of an inch, there's going to be some rounding going on here, will 16-point font, which is about 0.222 inches, that's 222 thousandths. There's the tenths, hundredths, thousandths place. The thousandths place is the third digit up here. Let's take a look. So again, our after equals our before times the scale factor, which is our before was 0.222 inches times our scale factor, which is 2.75. Let's get our calculator out here. We've got 0.222 times 2.75, 0.610 or 0.6105. So 0.6105. But we're going to round that to the nearest thousandth. That's the third decimal place. Tenths, hundredths, thousandths. So we look to the next decimal place, and there's a 5 there, which means that we round the 0 up instead of leaving it alone. So our end answer is 0.611 inches. All right. Check. So I got a few of those for you to try out on your own. And let's look at the back side here. There's a problem with the copy machine. It says, a copy machine is set to enlarge an image 240%. If the original image is 3.5 inches tall, how tall will the enlarged image be? So again, after equals before times scale factor. Our before was 3.5 inches. Our scale factor is 240%. We need to turn that into a decimal. And 240% equals, we go, take our decimal point and we move it 2 spaces over to get 2.40 is our scale factor. Okay. Down here, for example, the scale factor would be 2.85. This one here, 2.19, and so on. 2.40. So our 3.5 inches is our original size, our before size. Our scale factor is 2.4. And use our calculator here. We have 3.5 times 2.4 makes 8.4 inches. And it doesn't say anything here about rounding, so that's just our end answer, 8.4 inches. All right, you got a few of those to try it on your own. Make sure you check your answers before you move on, and good luck.